Hello! Hope y'all had a happy Thanksgiving. I'm off sitting in a chair getting some chemo right now. Less than fun. But I've prepared a little video for you explaining how we can know two triangles are congruent without having to prove that all the sides and all the angles are congruent. So today you're going to listen to a video about 4-2 triangle congruence by SSS and SAS. You can prove two triangles are congruent without having to show that all corresponding parts are congruent. And in this lesson you will prove triangles are congruent by using either 3 pairs of corresponding sides or 2 pairs of corresponding sides and 1 pair of corresponding angles. So here's the postulate that shows that if you have 3 sides that are congruent, so this side is congruent to this side is congruent to this side, and this side is congruent to this side, therefore the triangles are congruent. That's all there is to this postulate. So in your Math Excel homework, you're going to have some proofs. Sorry about that shadow there. So let's look at this slide and this proof. It's saying you have 2 pairs of congruent sides. This side is congruent to this side, and this side is congruent to this side. What do you need? Well, this postulate shows you need 3 sides congruent. So that means you have to show 1 more side of the triangle is congruent, which is this side here. So let's work through the proof. Given that LM is congruent to NP, okay, because that's given here, then LP is congruent to NM is given here, so our answer here is just given. Then we need to prove that this line is reflexive to it, is congruent to itself, which is the reflexive property. Anytime something is congruent to itself, it's the reflexive property. Okay. So now we've shown that 1, 2, 3 sides are congruent, so that makes it so that we can prove that triangle LMN is congruent to triangle NPL, which is exactly what we want to prove. Okay, let's look at the next page of our notes. Now, the next page of our notes talks about an included angle. Included means between.
Mary?
You're going to want to write that down. So, if the word included refers to the angles and the sides of a triangle as shown below. So, angle A is congruent or included between side AB and side AC. Side BC is included between angle B and angle C. So that's all included means. Included means between. Okay. So that's the bell, which rings even when nobody's here. So the side angle side postulate shows that 2 sides have to be congruent and the angle between them, but you'll notice the A is in between the 2 S's. So what other information do you need to prove that triangle DEF and triangle FGD are congruent? Explain. Well, we have 1 side, 2 sides. If we want to use the side postulate, we'd have to prove this side is congruent to that side. So we'd say ED is congruent to GF. If we want to use the side, side, side. If we want to use side angle side, we have this side and this side. So we need to prove not that angle, this angle, because it's in between the two sides we have congruent, and this angle, because it's in between the two sides we have congruent. So we'd have to say angle EFD is congruent to angle GDF. Remember, we start away on one leg, then the vertex of our angle, and then the other leg. And we'd use that angle if we were trying to prove side angle side. So what other information do you need to prove triangle LEB is congruent to triangle BNL, this triangle? By side angle side. Well, we know this side, and we know this angle, and then we would need the side on the other side of the angle. So we'd need this side and this side. We need to know the side LE is congruent to side BN. I hope y'all are getting it by now, or at least sort of getting it. It's really that if you can prove three sides or two sides and the angle in between them, then you can prove congruence. So, would you use side angle side or side 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 to prove the angles, the triangle's congruent? Well, here we have a side, an angle, and the side, and the angle is between the two sides, so we'd use side angle side. Then let's go down here, and we see 1, 2, 3 sides are congruent to 3 sides. That one's pretty easy. Now this one, we have 2 sides and an angle, but if you'll notice, this side is not on the other side of the angle. The angle is not between the two sides. So this one is neither, because that angle has to be between the two sides. So this side would have to be congruent, or this angle would have had to be congruent. This one, we can see all 3 sides are congruent. But if we wanted to get fancy, we know that that is a set of vertical angles, and vertical angles are congruent. And if we know this side, the angle, and that side, the angle is between the two sides, so you could also use side angle side. All right, let's flip to the last problem. This one is a little less pretty, and I promise there are only 5 homework questions, and this is only one of the 5 homework questions. Basically, we have 2 triangles, and they're just generic triangles. These are totally not drawn to scale. So we have triangle A, B, C, and triangle D, E, F. And we need to make sure that these triangles are congruent or not congruent. We just need to know. So we're given some points, so we can use the distance formula, which I've given you right here, to determine if the sides are congruent. So we need to figure out sides AB, BC, and CA, the lengths of those. And then we're going to need to figure out side lengths DE, EF, and FD. So we've got a little bit of work to do here. So side length of AB is the square root of 5 minus 1 squared plus 5 minus 4 squared. 5 minus 1 is 4. And 5 minus 4 is 1. 4 squared is 16. 1 squared is 1. 16 plus 1 is the square root of 17. And it's okay to just leave it as a square root. We're not actually going to do anything with it. We just need to see if one of these side lengths is also the square root of 17. Okay, so now let's do BC. So we get the square root of 2 minus 5 squared plus 2 minus 5 squared equals 2 minus 5 is negative 3. So we need to do negative 3 squared plus negative 3 squared. So we get negative 3 squared is 9. 9 plus 9 is 18. Square root of 18. And that's going to be side length BC. Okay. Next, we do CA. Now, CA is going to be 2 minus 1 squared plus 2 minus 4 squared. So we get 1 squared plus negative 2 squared. And I do these parentheses around the negatives because if you put it in the calculator, make sure you put this parentheses or you'll get the wrong answer. So negative 2 squared is 4 plus 1 is the square root of 5. Great. Now we have one triangle. Let's get the other triangle taken care of. So, triangle D, or side length DE is the square root of negative 1 minus negative 5 squared plus 0 minus 1 squared. Negative 1 minus 5 is the same as negative 1 plus 5, so that's the square root of 4 squared plus negative 1 squared. 4 squared is 16, negative 1 squared is 1. We end up with the square root of 17. So DE, they sure are ringing the bells today, is the square root of 17. Next we have EF. So we do the square root of negative 4 minus negative 1 squared plus the 3 minus 0 squared. Negative 4 minus a negative 1 is the same as negative 4 plus 1. So we get the square root of negative 3 squared plus 3 minus 0 is 3 squared. Negative 3 squared and 3 squared are 9. So 9 plus 9 is 18. We get the square root of 18 for side length EF. Now I know many of you are tempted at this point to say, they're congruent, except we don't really know for sure. This could be something like 7. You know, we just don't know. So we have to do this distance formula one last time. We find FD, where we say negative 4 minus negative 5 squared plus 3 minus 1 squared. Negative 4 minus negative 5 is the same as negative 4 plus 5, which is 1. So that's 1 squared plus 3 minus 1 is 2 squared. 1 squared is 1, 2 squared is 4. We ended up with the square root of 5. And if you look at that, we end up with congruent triangles. Yes, they are congruent. It's a little bit of work, but I'm confident in your ability to add and subtract, and I know you can do this, and I will be back on Tuesday, so tomorrow, and here's my email if you have any questions that you can't figure out with the help me solve this or the view an example. Okay, I hope you all had a happy Thanksgiving. Get started on your homework.